The previous video was about getting started with FastAPI. In this video, we'll look at how to build out the endpoints of a REST API. The demo app will be the traditional to-do list, but it will show an example of how to handle the different HTTP methods and work with data in a FastAPI application. We won't use a database for this app. That will be for a future session. Again, we will be creating a to-do app. It will have 5 endpoints. There will be 2 get endpoints, one to list all to-do items, and another to get the details of a to-do item by its ID. The post endpoint will create a new to-do item, while the put endpoint will update an existing to-do item. Finally, the delete endpoint will remove an existing to-do item. Let's take a look at how FastAPI represents data. And the answer is that FastAPI itself does not have any strong opinions about representing data. But since FastAPI is built using Pydantic, let's use that to represent the data. Pydantic is a Python package for enforcing Python type hints at runtime, and the package includes a base class we can use to define the expected structure of a JSON payload. Let's go to Visual Studio Code. I've already got a virtual environment set up with FastAPI installed. The class in the Pydantic module that we need to use as a starting point for those model classes is baseModel. Now, create a to-do-item class that subclasses baseModel. Each data point in the class is an attribute that is also annotated with a Python type hint. Let's take a look at how to use the to-do-item class. In the terminal, install the Python package IPython. IPython is an enhanced REPL that gives you many features that make working with Python in interactive mode easier and more productive. Run it with the IPython command. Import the to-do-item class from main.py and create a new to-do item. The attributes of the class become keyword arguments to the initializer. Now print the to-do item. The baseModel class provides a user-friendly implementation of the dunderStir method that lists the attributes and their values. It also includes the modelDump method that generates a dictionary representation of the attributes. Again, Python dictionaries translate well to JSON objects, but you don't need to do that because the baseModel class has the modelDumpJSON method to generate a JSON representation of the attributes. The point is that the Pydantic base model will be a good choice for representing data in a FastAPI application. Exit IPython with Ctrl-D and press Enter. In main.py, create a list and populate it with several to-do items. This will serve as the database for this video. There will be 2 endpoints that respond to the getHTTP method. The first one will return all of the to-do items in the database. It simply returns the to-do-db list. FastAPI knows how to transform a Python list to a JSON array, and Pydantic knows how to transform the to-do-item class to a JSON object. This means we don't have to worry about creating JSON representations in the handlers. Run the application with Uvicorn and go to localhost 8000/docs in the browser. Expand the /todos endpoint and click the Try It Out button. Then execute it. You'll see a JSON representation of the to-do list. Go back to main.py. FastAPI also lets you specify the response model of the endpoint. In this case, it is a list of to-do item. Start by importing the list type from the typing module. Next, set the response model keyword argument of the get decorator to list of to-do item. Save main.py and the application will restart thanks to the reload option. Go back to the browser and refresh the documentation. Execute the /todos endpoint again. The data returned won't change, But if you look below, you'll see more information about the types of the data. The schemas are represented by the response model keyword argument. Now we need to get a to-do item by its ID. Create a new handler function in main.py that accepts an integer. Remember to use type hints to tell FastAPI that the ID should be an integer. In the function, iterate over the to-do-db list. Compare the ID of each to-do item to the ID passed to the function. If a match is found, return it. This assumes that a valid ID is passed to the handler function. If a non-existent ID is provided, we need to raise an HTTP exception, and this needs to be imported from the FastAPI module. Back in the getToDoById function, on the last line, raise the HTTP exception. It takes a status code. In this case, since a to-do item with the ID cannot be found, a 404 status code should be returned. And we can also provide a message to the user. Now add the getDecorator to the function. The path includes a variable in the second segment. It matches the name of the parameter to the getToDoById function. Thus, whatever value is in the second segment of the path will be passed to the getToDoById function. Now for the response model. The expected type is a to-do item, so the response model keyword argument is to-do item. Save the file and reload the application. Head back to the interactive documentation and refresh the page. Expand the endpoint for the get method that accepts a to-do item ID. Click the Try It Out button. The interactive documentation now has an input box for you to provide a to-do item ID. Notice that it is required, it is an integer, and is part of the path. Enter 1 and click the Execute button. As expected, the application returned the first to-do item. Enter 2 and click the Execute button. The application returns the second to-do item. Now enter 200 and click the Execute button. The application returns a response with a 404 status code, and in the body, it returns the detail message from the HTTP exception. Go back to the input box and enter ABC. Click the Execute button. The documentation won't let you do that because the string ABC can't be cast to an integer. But look at the response. It still has a 404 status code and the detail message from the previous response. So the interactive documentation didn't even fire off the request. This is a shortcoming of the interactive documentation if you try to use it as a testing tool, which it is not. It's useful, but it's not a silver bullet. To see how the API responds to an ID of the wrong type, we'll need a client. Instead of writing one, we can install a Visual Studio Code extension. Go to the Extensions panel by clicking this icon in the sidebar, or use the shortcut Ctrl-Shift-X, which is Command-Shift-X on Mac OS. In the search box, search for REST Client. Install this one by Huaqiao Mao. Go back to the Explorer panel and create a new file. The name doesn't matter as long as you use the .http file extension. I'll call mine api.http. In this file, you will create requests, execute them, and view the response data. Enter get http localhost 8000/todos on the first line. Above the line, a link to send the request will appear. Click it. A new pane will open with the response, and you can see at the body includes the JSON for the list of to-do items. On the next line, put 3 hash marks. And then on the new line, duplicate the request from before, but this time with an ID of 200. When you click the Send Request link, you'll see the response with a 404 status code. Let's try one more. Again, on the next line, place 3 hash marks, and then on a new line, create a request for a to-do item with an ID of ABC. Click the Send Request link and look at the response. It shows a status code of 422 for an unprocessable entity. In this case, it is referring to the value ABC for the ID of the to-do item. The handler function annotates the to-do ID as an int, and the string ABC cannot be cast to an integer. And the message in the detail describes this. Creating a new to-do item is done with the post-HTTP method. But first, let's write the handler function. Notice the use of the to-do item type hint. This will tell FastAPI to look for JSON in the body of the request with the data to create a new to-do item. But there is a problem. The to-do item class has an ID attribute. Obviously, we don't want users providing the IDs of new items. We want to let a database do that. So we can either ignore the ID attribute, or we can write a schema, subclassing base model, with only the attributes needed to create a new to-do item, namely task and complete. And the type parameter of the new to-do function becomes create to-do item. Now we have to generate an ID for the new to-do item. Again, in an actual database, we would let the database take care of this. For the demo, I'll write a simple function that gets all of the IDs in the to-do-db list, find the maximum, and add 1 to it. Now we can finish the handler function. Create a new to-do item and fill it in with the ID and the task and complete from the create to-do item. Add the new to-do item to the list and return it. Now add the post decorator to the new to-do function. The path will be /todos with no variables. And the function returns the new to-do item, so the response model will be the same type. According to the REST standard, a request that creates a new item should have a 201 status code in the response. This can be done by adding the status code keyword argument to the post decorator. Save the file, return to the interactive documentation, and refresh the page. Expand the post endpoint and click the Try It Out button. The text area contains JSON with the keys for the required attributes in the Create To-Do Item schema. Fill out the values in the body. Notice that false is not capitalized because this is JSON, not Python. And click the Execute button. FastAPI returns the new to-do item. Notice that the ID is 3, which is one more than the maximum ID before adding the new item to the list, and the status code of the response is 201. Go back to the JSON in the request body and remove the complete key. Execute the endpoint again. FastAPI returns a 422 status code again for unprocessable entity. This time is because both the task and complete keys are required. Let's implement the put HTTP method handler to update a to-do item. This will use elements of both the getDetail and post endpoints. Start with the put decorator. The path will include a variable for the ID of the to-do item needing an update. And it will return the updated to-do item. Thus, to-do item is the type for the response model keyword argument. Define the handler function. It will take both an integer ID of the to-do item and a create to-do item. The create to-do item will hold the updated data. This function won't do anything yet, but I want to show you something before going much further. Save the file to reload the application and refresh the interactive documentation. Expand the put endpoint. Click the Try It Out button. There is an input box for the ID. I'll enter 1. The text area again expects JSON. Suppose that we want to mark the to-do item as complete. There is no reason to update the task, so I'll delete that key. Now click the Execute button. As we just saw with the post endpoint, both the task and complete are required. Omitting one or both is rewarded with a 422 status code. And for creating a new to-do item, this makes sense. But we might not want to update all of the attributes of a to-do item. So we need a new schema. Create a new schema, subclassing the base model for updating a to-do item. Add the attributes for the task and complete along with type hints. So far, except for the class name, this is exactly like the Create To-Do Item schema. Now we need to make both of the attributes optional. Import the optional type from the typing module. Annotate the task attribute to be optional of stir, and set the default value to none. This way, if it is omitted, we can check for none to disregard it during the update. And do the same with the complete attribute. In Update To Do, change the type of the update info parameter to Update To Do Item. Get the to-do from the list and use the update info to modify it and return the updated item. Or raise an HTTP exception if it can't be found. Save the file and return to the interactive documentation. Refresh the page. Expand the Get endpoint for all to-dos and execute the endpoint. Notice that the to-do item with an ID of 2 is not complete. Let's mark it as complete. Expand the Put endpoint. Click the Try It Out button. In the input box, enter 2 for the ID. In the text area, delete the key for task. Click the Execute button. The endpoint returns the to-do item with an ID of 2. However, notice that the complete key is now true. Go back to the Get endpoint for all to-do items and execute it again. Notice that the complete key for the to-do item with an ID of 2 is still true. The update worked. Now let's see how to delete an item. The delete HTTP method handler simply looks for the to-do with the ID in the to-do DB list, and if it's found, it removes the item from the list. Otherwise, it raises the HTTP exception. Notice that once the item is removed, nothing is returned. This is also following the REST standard that a successful delete should return no content. This is also why the delete decorator status code keyword argument is 204 for no content. To try it out, save the file and head back to the interactive documentation and refresh the page. Find the delete endpoint and expand it. Click the Try It Out button. Enter 2 in the input box for the ID. Click the Execute button. Notice the status code of 204, and there is no content in the response body. Expand the Get endpoint for all to-do items. Execute it, and notice that the to-do with an ID of 2 has been removed. You could also go back to the api.http file and execute requests for any of the endpoints. For example, to create a new to-do item, add 3 hashtag marks on a new line, and then post to the /todos endpoint. Add a header to set the content type of the request to application/JSON. Next, add a blank line, and then the body, which is going to be JSON. Click the Send Request link, and look at the response. It returns a new to-do item with an ID of 2. Click the Send Request link for the GET request from before, and now it shows that there are 2 to-do items in the list. And that's a complete implementation of a simple REST API. This video didn't go through all of the details. There's much more to be done, such as using a real database to manage the data. In the next video, we'll do that. We'll also see how to use SQL Alchemy to avoid SQL queries and write Python code to manage the database instead.